Okay, this is Andrew McNamer with part 7. This is going to be the client-side prediction. And so, before I start, as you can see, we have the simulated loss, minimum latency, and random latency set to the same values from the server, or from the lecture, on both. And we are going to go ahead and get started. And as you can see, the player jumps back and forth while it's predicting. So what's happening is it's trying to predict where the forward momentum is going to take the player's ship, and then when it gets a new message from the server that isn't dropped, it updates the position, which is why we get the janky thing here. And as you can see with the missiles too, it also does the client-side prediction where the missiles jump back and forth depending on where its prediction location is versus the real location from the server. So this is, and as you can see also for the difference between client-side and server-side with the Dead Reckoning, the messages are going up exponentially per second and as the time goes up. So we were sending thousands of messages on both. But here's the client-side prediction. I'm going to go ahead and minimize server because we don't do anything on server. So the player prediction control, which is set in the ship and missile objects, gets the current position of the game object. We set the game object in here so we can use it in the execute. Last time set, we get the current time. Last velocity set to 0, and then get the radian of the current angle of the game object and set that here. When we do move to prediction, which is going to be in game scene play, we get a new position based on the current position, the delta time between the current time and the last time set, multiplied by the velocity that we last got. So when the ship starts, the prediction control is going to be 0 because there's no velocity. When we get a new message in, we're going to get the updated position and missile set. So when we get that, and it'll update the last velocity, time set, and angle and position. So we set the position and angle based off of that, and then in set we are checking if the time update is not an old message, because sometimes we get old messages in here. So I had to clean this up with an if statement. Then we set the velocity because the velocity was being inverted and all over the place. So that's that one. In the missile position update messages, we're getting the position, the angle, and the ID as well. So we serialize that as normal. And then when we execute, we get the player missile, and then we set it based off of this. Same thing with the ship. This is the same, although we set it by the PPP control. Set the position and angle, because we are not... Oh, we are. Sorry. We are setting it by the PPP control position, which is the player prediction control in the object. We are setting the position and angle, as well as here we are setting the position and angle before returning the message to the pool. So that's where the set comes in, and then move to prediction is used on a per frame basis where it just predicts where the next position likely is. And that happens in game scene play, where we move to prediction, and then for each missile in the missile list, we move to prediction for M, and then the same thing for player 2. And that is the client-side prediction.